在今年的5月份，盖亚的科学家公布了他们发现的一颗黑洞，这颗名为盖亚 BH3 的黑洞非常特殊，是目前银河系内已知的第2大质量黑洞，拥有33倍的太阳质量。而像这类大质量的黑洞，之前只是通过引力波探测器在其他星系中发现过，它的成因目前还是个未解之谜。而这次在银河系内发现的这颗黑洞，就很有可能会帮助我们揭开恒星级大质量黑洞形成和演化的秘密。这并不是盖亚卫星所发现的第一颗黑洞，在2022年，盖亚卫星就已经发现了一颗距离我们1500光年的黑洞，它是目前已知距离我们最近的黑洞。为什么盖亚卫星可以发现这类非常特殊的黑洞？关于发现银河系内已知第2大质量黑洞的背后又有什么故事呢？我邀请到了参与其中的科学家 Aminia 同时也是研究银河系演化世界最顶尖的科学家，让他和大家分享一下发现一颗黑洞背后的故事。
Gaia measures the proper motions of stars, and stars move around the galaxy. In the first kind of data reduction, or the first pass, you assume all stars are isolated, they're single stars. So this is basically how this one star was discovered. It was doing these wiggles.
想要了解盖亚是如何发现黑洞的，以及阿米娅说的摆动是什么意思，我们首先就要了解一下盖亚的探测原理。盖亚卫星主要的科学任务是通过视差法来测量恒星的距离，从而绘制出恒星在银河系内的3维地图。视差法是如何测量恒星距离的？这里我做了一个小动画来演示一下。盖亚卫星会围绕着太阳在 L2 的轨道上公转，在公转的时候呢，它会巡天扫描进行天体测量。在不同时间下测量的恒星会在背景天空中留下一个环形的轨迹，这个环形轨迹完全是因为望远镜本身公转产生的视差所引起的。距离近的恒星会在天空中留下一个比较大的环形，距离远的恒星会产生一个小的环形。运用基础的三角函数就可以由此推断出来恒星的距离了。这是一个非常理想的情况，因为恒星相对太阳是静止的，实际情况是所有的恒星都是有自身运动方向的。当把这些因素考虑进去，盖亚测到的轨道将会是这个样子的，也就是Aminia所说的摆动了。
But now the data is becoming better, and so you begin to see wiggles that are due to stars orbiting each other.
随着对盖亚数据分析能力的增强，像这样的环形的双星系统也能被解析了出来。但是这也出现了一些非常特殊的案例，例如有些天体既不遵循单个恒星运转的轨道，又不像是双星系统一样拥有一颗伴星。
And these wiggles are rather large, and then if you look to your solution, then you basically see there is no other star that's producing those wiggles. And so what the team did is then they got spectra to confirm this, the radial velocity, so you also see variation in the radial velocity, so indeed the signal is real.
So make sure the data is real.
Yes, indeed, you have to validate it. You have to demonstrate that it's not a problem of the satellite, but if you observe it with other telescopes from the ground, you also see this variation. And from the variation, you can actually tell how massive this other object is, which is this 33 solar masses dark object. Unbelievable, amazing, it's fantastic, absolutely fantastic.
在经过多重验证之后，团队确认了这颗 0.76 倍太阳质量的恒星拥有一颗33倍太阳质量的黑洞伴星。这个双星系统的周期为 11.6 年，距离我们1900光年。黑洞运行的轨道大小接近于金星的轨道大小，那这颗恒星运转的轨道呢，相当于是海王星的轨道大小。而我们目前已知的恒星演化模型无法解释出来这样大质量的恒星黑洞是如何形成的，因为通常大于30倍太阳质量的恒星呢，会在演化过程中损耗掉大部分的质量，最终形成的黑洞呢，也只能是在20倍太阳质量左右。那令 Aminia 惊喜的不光是这里的33倍太阳质量，而是环绕黑洞的这颗恒星所具有的物理性质以及它所在的位置。
But what's even more amazing, was amazing to me, is that if you actually look at the chemical abundances of the star that accompanies this black hole that orbits around this black hole. It's very metal poor.
Metal poor. Okay.
It's a halo star. And so I'm an expert in the halo, right?
Yeah.
And so when I saw that star and I saw the metallicity, I said, okay, this star was accreted. And it's actually part of a stream that we were studying, that we had discovered with the Gaia DR3 here in our team. That's known as ED2, and ED comes from it's the initials of a student of mine that's sitting next door, Emma Dodd, and she had identified this clump in energy and angular momentum, as I was telling you, and we were studying the properties of this object to try to determine, what was the parent, what was the system in which this object had formed. And so it turns out it's probably a star cluster of rather small mass. So the black hole formed in a star cluster that likely was accreted by the Milky Way. So it's also a foreign object.
Yeah.
So it's just unbelievable that all of the coincidences that
那这未免也太巧了吧，这颗恒星正好撞上了 Armenia 的研究领域，而这个双星系统呢就在他们之前发现的星流之中，这会不会揭开大质量恒星级黑洞形成之谜呢？
So I think, we have no idea of the black hole mass function, right? And you have the gravitational wave detectors that are finding these black holes that are a bit too massive to be stellar. So we'll be able to kind of, from the perspective of the Milky Way, establish that much more firmly what is the mass function of the black holes, which then tells us about the mass function of the stars that produce those black holes and the processes by which these black holes are built. So that would be fantastic, actually, because it formed in a cluster. That's also another channel. That's a rather common channel for forming black holes and for growing black holes. So that's also an interesting coincidence, because it also then links to what gravitational wave detectors and the community wants to measure.
Yes, right.
What's interesting about this BH3 is that it's 30 solar masses. This is also a peak in the distribution of black holes that gravitational wave detectors find. So why this coincidence, I don't know. We need more, and then we can tell whether this is a coincidence or there's something physical. And we expect Gaia will discover more of these objects, probably of lower mass, and probably slightly further away, because this was rather nearby. Now within Gaia there is a task force to identify objects, basically identify objects that show large deviations from being. So you have to develop pipelines that would recognize binary stars, that would recognize also binary. So if both are stars. But I would also recognize anomalies in terms of black holes, but also exoplanets.
好了，这就是这期视频的内容了。如果你喜欢物理，喜欢天文，别忘了加关注。我们下期视频再见吧，拜拜。